In the last video, we learnt about the basics of the difference equation and how the discrete time analysis is introduced. And now we are going to understand the way of solving the difference equations. The first way is the iterative method, and basically iterative means something which is repetitive, in which something gets repeated. When something gets repeated, we are able to extract a format out of it. We know the pattern of it, and that can help us to develop the time path, because just like in differential equations, we develop a time path in the difference equations. So it can be understood with the help of an example. Let's take this example, which is from the book of Alpha C. Chiang. The initial condition is given, and here you can see not is not written after the variable y or in parentheses, rather it is written in the subscript. This is the way of writing the difference equation variable, and this is the equation which is given. We have the main variable, or the variable in current time period, and the variable in next time period. Now we can do this by experimenting with different values of t. The value of t is now being experimented. The experimentation table is developed here. Let us focus on it. We are going to put various values of t for the sake of experimentation. In this column you will see how we do the substitution in this equation, and then we solve it and see what is the result, and finally we develop it in the final form. So if t starts with 0, we are going to put 0 here and then 0 here. As you can see, we have zeros here, and then we can simplify it. It will be y1 is equal to y0 plus 1. So this is the final form, or the final result of the substitution. Now if we consider t is equal to 1, instead of 0 we will see 1 here again. So after putting this, we remember that y1 is already quantified. So this y1 can be substituted here, and this is what we have written here. So this y1 gets substituted here, and we get this term. Simplifying, 1 plus 1 becomes 2. So this is the second form in this series of forms. T is equal to 2, and when we put it equal to 2, it appears like this. This is the the value of y2 that we have found in the last step, that we can substitute here, and it will look like this. And then finally we can add these two values to get 3, and this is the final form. Again, t is equal to 3. When we substitute it, we get this form, and then we realize that yt is already found, and then yt, its value is being substituted, and then after substitution we can add these two values to get 4. So in this way it is getting developed. 4 of the values have been used, and we are able to get the results for that. So we can follow this pattern and say by saying that so on up to a certain value, and that is t. So now the final value of t would be t, the maximum value, and generalizing the pattern, we can write 4 instead of this box where we had 4, we can write t, and here again it is t, because this is the substitution that we are observing, that whenever we put a certain value, it continues in the subscript, that is 1 2 3 4, and it goes down to this level. And here 1 2 3 4, you can see it is adjacent, 1 2 3 and 4, and then we can call it t, and this can become t, because it's a variable that is varying over time with a certain repetition or iteration in it. So the solution would be this, where yt is on the left hand side and the initial condition is there, and yt is there. One of the benefits of substituting is that finally we get y0 in all of the results, because we remember that in the time path we are looking for the definite solution where there is no arbitrary constant, or where the initial condition is present. This is the current value of y, this is the initial condition, this is variable t, this is the equation that we wanted to solve, this is the first order difference equation that we wanted to solve. So the identification of having a certain solution is that we don't have any lead or any lag in the solution. You can see it is yt or y naught. There is no lead and there is no lag. Y naught is equal to 10 is the initial condition that we are substituting here, and yt is equal to this because we know that y naught is equal to 10, so we substituted it, and finally the answer is this. Since we had the initial conditions value, so we substituted it here. Now it is very easy to plot this time path because it is simply the addition of 10 and 1, that is 10 and t. For example, 10 plus 1, 10 plus 2. In this way we can develop a number of values and then we can plot them and get a time path. 10 plus 1, 10 plus 2, 10 plus 3. We are able to make this pattern, and this time path will be developed. This was an additive case. However, in the difference equations the situation can be multiplicative as well. For example, in this case we have y naught, which is equal to beta, the initial condition, and this is the difference equation that we are trying to solve. So we do the experimentation here, and in the experimentation we have t is equal to 0, 1, 2, 3 up to the highest value of t. So putting the value just like we did in the last example, we will get, I'm highlighting these for your convenience. Now we have substituted these values, and then y1, y2 and y3, their values were substituted here, and due to that we were able to get answers in terms of y naught because all of these are having y naught. So as a result we have y naught in all of these values. So the final form here is this, in which the y naught is appearing in all of the values, and 1, 2, 3, 4, 5 up to 4, and then 1, 2, 3, 4, 5 up to the highest value, that is t. Alpha is kept as it is, and y naught is kept as well. Y is also kept as it is. So this is the development of the solution, and it is a solution because it doesn't have any lag or lead in it. It is free of any lag or lead. It is the value of yt. So this is it, and this was the difference equation that was given, which is having a future value of y. So we can further simplify this given this solution that we obtained. This is the initial condition, and I can put y naught is equal to beta here. When we did this, we get this final result. This is the definite time path, because in this definite time path we do not have any arbitrary constant. We have a solution which is definite, and we can now plot this time path, and it's a solution of a difference equation. These were the two numericals that we did in this process, and both of these numericals were done by using the first method of solving the difference equations, which is the iterative method of solving the difference equations. In the next video we will learn about the formula that we can use to solve the difference equations, which will be the second method of solving these equations. Thank you.